let's come back to this. I'm going to rewrite it. X squared minus 2x plus 4. X squared plus 2x plus 4. Okay. Now you remember really early on when we said, oh, okay, as we were going through this process, we noticed that there were no solutions to these guys. Okay. And the way we noticed there are no solutions is because you try, and you can't factorize. Okay. Now there's a quick way to work out that you can't factorize without even trying to factorize. And it's called, here's where I'm leaning forward, we're going to learn this in more depth later, so don't freak out if it's a little bit confusing. It's called the discriminant. Now what is the discriminant? I'm going to put this in a different color off to the side because it's a side note, and then we're going to bring it here. When you are solving any quadratic formula, if it's nice and neat, you do your, think of a pair of numbers, right? They add to this, they multiply to this, and then off you go, okay? But when it's messy, or they're, you're going to get irrational roots, what do? You can't factorize so nicely. You can't just think of, might be root 3 or it might be root 5, right? What do? Quadratic formula. The quadratic formula. Now the quadratic formula, who remembers where it comes from? Like where does this jumble of A's and B's and C's? Yeah? Okay, so it comes from this. It comes from this guy. But what's the process? What's the process that gets from here all the way to here? It has a name. Starts with C. It's a phrase. We complete the square. You take this guy, right? You have to divide through by A, and you do this rearranging and crazy stuff, and here's what you end up with. It's ingenious, right? It takes something that's quite hard to deal with, and it just makes it as automatic as tiny shoelaces. Okay? Now here's the important thing I want you to notice about this. See this part that's under the square root? This part that's under the square root is critically important. Okay? In fact, let me try and show you why it's important and what it actually means, right? We put this all over one denominator because we can, because it's neat, right? But actually, when you do this whole process, you get these two parts separately. You get the plus or minus part when you take a square root, you get rid of the x squared, and then you get this part by doing some other algebra stuff. So really, it's this. Okay? And then, because it's like, oh, it's the same denominator, why wouldn't you combine them? Okay? Now, I hope you recognize that there are two parts to this. What is this guy? What is that guy? That's the axis of symmetry. That's the middle of the parabola, because every parabola is symmetrical, right? Which is why, by the way, that's why I knew when we were doing that other one, this one, and we did this part, and then I did this part, the reason I know, this can't be a parabola. It can't be a parabola. It's not symmetrical. Do you see that? Like it's doing something different here than it's doing there. So that's why it's like, it might look like one, but it's an imposter. Okay? So therefore, I've got my axis of symmetry. There's the middle. Bam. Okay? You add something, and you take it away. And that gives you two roots. Okay? Of course it gives you two roots, right? Let's just picture a really simple parabola. Here's one. Okay? There's your axis of symmetry. And because it is the axis of symmetry, you go the same distance that way and the same distance that way, and it gives you two roots, which is what this whole thing is after. Does that make sense? Are you still on board? Okay, so far so good. Now let's just think about some things here, right? Suppose, for instance, this guy here, b squared minus 4ac, suppose it's 0. Suppose 0. What does that mean about where the roots are?
One solution.
There's only one root, because it's the axis of symmetry plus or minus nothing, right? So therefore, where's the root? Answer, the root is where the axis of symmetry is. One root, right? Okay, let's think about what happens if this number, b squared minus 4ac, as it gets bigger and bigger and bigger and bigger, okay? The roots get further and further and further apart. Does that make sense? Okay. All right, so we thought about 0. We thought about what happens when you get bigger. What happens when you get smaller? Answer, it breaks. It breaks. We thought about this under domain and range, right? If this guy is negative, you're in trouble, right? Not only do you not have one root or two roots that are getting further and further apart, how many roots do you have? No. You don't have roots. There's no real roots, okay? There are no real solutions to that. So therefore, this guy under here, this number, b squared minus 4ac, it discriminates between all the different kinds of quadratics you have, right? It discriminates between the kinds that have no roots, or the ones that have one root, or the ones that have two roots. Because it discriminates between them, it's the really important factor. We give this thing a special name. We call it the discriminant. Okay? That triangle, Illuminati confirmed. I know you're thinking it. It's a triangle because it's the Greek letter. Does anyone know what Greek letter is? It's delta, D for discriminant. Okay? So this guy here, right? Here's what I know. Let's think about those three things you just told me. If the discriminant's equal to 0, right? Equal to 0, that's the first thing we started with. Then there is one real solution. You agree? Okay. Yes, that's right. Okay. If there is a discriminant that's positive, how many solutions are there? There are 2 real solutions, right? And if the discriminant is negative, it's not real. There are no real solutions. You'll never solve that thing as hard as you try. Okay? Does that make sense? Okay, now get ready to make a conceptual leap. Okay? And if you don't make it, that's okay. Just try and stay with me. The next bits will make sense. They'll just be still a little bit more confusing. This whole thing, right? I want there to be real solutions. Do I not? Right? That's the domain. There have to be real solutions. So therefore, when I look at this set of things here, right? It has to be one of these 2 cases, right? I have to get real solutions because that's what you told me in the first place. That's what I can see from the graph, right? So if there must be real solutions, then this thing must be true. I can put those into one, can't I? I can say the discriminant can be greater than or equal to 0. If I can satisfy this, right, real solutions, then this will tell me something about this, okay?